2 years ago, here at Airbus Industry in Toulouse, in July 1986, we made a film using an A300 flight testbed to show you what we believed would be possible with a fly-by-wire system in a modern transport airplane. Today, that airplane, the A320, is a reality. In a few moments, we will show you precisely the sort of advantages that the flight control system will bring that airplane in flight. But first of all, I'd like to show you the cockpit of the airplane, to show you what a neat and spacious cockpit we have in the A320, and particularly the flight instruments, so that you'll better understand what we will show you in flight. In this wider view of the cockpit, you can see again the advantages that we gain from the two primary features of this airplane, its fly-by-wire flight control system and the CRT displays, which give us such a very nice open area in front of the pilots without any clutter from conventional control columns. Pilots can see their primary flight display, the navigational display, the engine instruments, normally on this part of the upper CRT, the systems display presented here either manually or automatically in case of failures, and of course repeating for the captain, the navigational display and the primary flight display. The center console of the airplane, the pilots have individual controls for the flight management system. They can introduce flight plans through the keyboards here. The controller here in the center is for the central warning system display of the airplane, the systems display particularly, where we can individually display any system that the pilot desires. The throttle levers of the airplane move in a conventional fashion, including into the reverse range. Beside them are the pitch trims, used only for setting the pitch trim on the ground. Here we have the engine master levers. Behind that, the control for the air brakes and the flaps. The A320 is flown by the pilot manipulating the side stick controller, which you can see here in my left hand. It's a very nice sized controller. It comes very neatly to hand. It's solid, firmly mounted. It has on it an autopilot disconnect button and a radio transmit switch. It moves over a comfortable range for the pilot's hand, flying the aircraft nose down in this sense, nose up in this sense, turning to the left or turning to the right. Let's look in the A320. We have flex thrust, speed rising both sides. Note the speed trend arrow, which is very good on the airspeed indicator. And we're going to do an engine failure on takeoff.
Rotate.
Rotate. Positive climb, gear up. I take my hand off the controls and an engine failure, please. So hands and feet are off the controls, and there's my left hand to show you that I'm not touching the side stick. And you can see, in fact, that we have virtually no change in pitch attitude or bank angle, and I have a large indication here that I have an improper side slip situation. If I apply right rudder normally to get that into the middle, when it's in the middle, it will give me the optimum side slip situation to put the ailerons to zero. I'll just level the wings gently there for a moment. And if we can look at the flight controls page now, you can see, in fact, that the ailerons are fairly close to neutral. We have no spoiler extension with that situation. And that's the airplane's total reaction to an engine failure which is not controlled by the pilot. Okay, I think nothing more will happen now. We will take back control and continue with the flight. The characteristics of the flight control system in the A320 are that if the stick is free, as it is at the moment with the autopilot disengaged, the airplane will maintain 1G flight in pitch, corrected for bank angle and pitch attitude, and 0 roll rate. and it is this which gives the airplane its nice characteristics of flight path stability in the short term, which is so attractive to the average pilot. Okay, you can see that I'm not touching the controls. My hand is free for the controls. You can see that the airplane is maintaining its pitch attitude and its bank angle. If I change the pitch attitude and I release the stick, then the pitch attitude is stably maintained. Similarly, if I roll the airplane, you can see that we have now a steady bank angle, and that bank angle is maintained along with the pitch attitude. However, if I go to a bank angle which is inappropriate for a civil transport airplane, beyond, in this case, 33 degrees, if I go to 45 degrees of bank, if I release the stick at this point, now you can see the airplane returning to less than 33 degrees of bank on its own. These are some of the continuous features of the fly-by-wire control system, which are rather nice. We'll demonstrate now the overspeed protection system. I'll pitch the airplane nose down to a fairly steep pitch attitude, and I'll roll it to a reasonably high bank angle. You can see us accelerating. You'll hear the overspeed warning in a minute, which will stop when it sounds. I release the side stick, and we'll see what happens. Here comes the overspeed warning now. Stop. You can see the airplane rolling out on its own and pitching back up. The speed has stopped increasing. We've only in fact exceeded VMO by 12 knots. And you can see that the airplane is now climbing with the speed reducing towards the safe sector. In fact, when it gets to the two little green lines, which you may be able to see just under the speed trend arrow, the speed will stabilize and the airplane will maintain that safe flight path until the flight crew. So what we'll do now, in fact, is to come to a typical approach situation where we're flying the airplane at about the reference speed, and the top of the amber sector there automatically gives me the minimum reference speed for the approach configuration or landing configuration that we've set. So I'll take typically VREF plus 5 knots, which would be perhaps a normal approach speed for the airplane, with a thrust that will give me 700 or 800 feet a minute rate of descent, to represent here at 9,000 feet a typical approach situation. And we'll assume in a moment that the windscreen is full of an Aztec or a mountain or something, and we have to make an avoidance maneuver. So here we go. I'll add on full thrust and pull full back stick and roll the airplane to 20 or 30 degrees of back. So 3, 2, 1, go. Full thrust, full back stick, holding it. You see how rapidly the pitch attitude increased to 25 degrees. We roll to the bank angle that we want, but the speed and the angle of attack have remained totally in a safe range. And the airplane has, in fact, incredible maneuverability in this region, which is, as you saw, very close to the storm.
The A320 flight deck is substantially the same as that of the new A330 and A340, leading to major economies in operation. For well over 50 years, the story of air transport has been the story of the progressively more complete integration of electronic aids to more reliable, more profitable operation in all phases of flight. Europe's major aircraft builders have a long tradition of leadership in this process of constant evolution. United in Airbus industry, they are maintaining the tradition with the A320, the most advanced airliner in service.